The vertices of triangle ABC are A 4, 0, B negative 2, 4, C 0, 6. Move through the steps to find the coordinates of the orthocenter of triangle ABC. Now, honestly, all of these are way easier to find on paper when you can manipulate, turn it and draw things. I find them much harder to do on the computer than in real life. For example, the last one that we did with the triangle, finding the centroid, and then having to figure out what the coordinate is. Honestly, I've actually done something like that in real life, and I would never put it onto a coordinate grid and then do it that way. I would actually just take that triangle, measure it, find the center, connect those, and then just drill a hole right through it. But alas, we are not in real life. We are on the computer, so this is how we have to do things. So here we go. Graph triangle ABC. So first thing you're going to do is plot the points of A, B, and C that are given to you onto the coordinate grid. Next, you're going to find the equation of the altitude from B to AC. The slope of AC is negative 3 over 2. That's the slope here, right? If we're going down 3 over 2. So the slope of the altitude is going to be perpendicular to that. So it's going to be the opposite reciprocal, which is positive 2/3. So we know that we're going from B up 2 over 3. So we know that this is our line for our altitude of our triangle. Then they use point slope form to figure out what the equation for that line is. So they plug in the slope that we know we have to have. They plug in the point for B, which is negative 2, positive 4, right? Negative 2, positive 4. Don't let the minus sign confuse you because that's part of the original equation. They simplify it, distribute the 2/3, add 4 to both sides, and boom, the equation of this line is y equals 2/3 x plus 16/3, right? It's crossing right there at 5.3. Next, they do that for point A. Girls, in the middle of a video, not appropriate. I apologize. They do the same thing for point A. They know that BC right here is got a slope of 1 up 1 over 1. So that means that this slope is going to be negative 1, so down 1 over 1. Right, so we know we're going through here. They put it into point slope. They know we have a slope of negative 1. They know we have the point 4, 0, right, because A is at 4, 0. Distribute the negative 1, add 0 to both sides, which doesn't do anything. So we have the equation of y equals negative x plus 4. And then notice that we already have a line going through C right here, but that is not our altitude, right? So what we're going to do is we're going to look at these two and see where they coincide at. We're going to use the system of equations that we learned in algebra to figure this one out. I don't know why they're doing it through elimination. Honestly, I would just set them equal to each other. That would be way easier to say negative x plus 4 equals 2/3 x plus 16 over 3, but they're using the elimination method. So they multiplied the top equation by 3 to get rid of the fractions, which is not a bad idea. They multiplied the bottom one by 2 so that we can get some opposite coefficients going. And they get that y is equal to 24 over 5. With y being equal to 24 over 5, they plug that back into one of the equations and they solve for x. So the coordinates are going to be this point right here, right? There is a line that's going to go from C down here. it's really hard to see because it's so close to side BC. And it ends up at the point -4/5, 24/5, right, which is -4/5, +4 4/5. So that is our orthocenter right there. And your study tip, I know this video is a little long, I apologize. You can use the corner of a sheet of paper to draw the altitudes of each side of a triangle. The intersection point of the altitude will be approximate orthocenter of the triangle. What that means is when you have a triangle, if you take any straight edge, I just happen to have a nail file right here because I don't put things away all the time. Once you've figured out what that slope is going to be through that point, you put this going through those 2 points and just draw your straight line and do that for 2 of those. And where those 2 intersect, that is your approximate orthocenter.